Hi everyone, welcome back to Portfolitics 1.0. This is our second lesson for our second project. In this lesson, we are going to be taking a look at how to access Kaggle API, how to get data from Kaggle API, and how to clean a data set. First of all, we have to install Kaggle on our system. If you don't have Kaggle on your system, I mean on your Python environment, you install it by simply using the pip install Kaggle. You install that. After doing this, as you can see, because I have it already installed on my system, it's not bringing any installing process again. So after doing this is the first step. You install Kaggle in your Python environment. Afterward, you create Kaggle directory. And for us to create a Kaggle directory, we simply use this command, make directory. Directory is just a folder. Then you bring out the paths in which you want to save the Kaggle directory on your system, as in you specify the paths .kaggle. Then you run this, shift enter. We can verify this through our folder by simply checking it through this folder over here. Here is it, beneath this place. We just created that. Afterward, we create a Kaggle token. To create a Kaggle token, you utilize your Kaggle user profile. You have to open an account with Kaggle. Simply come to your Kaggle user profile over here. Here is mine. Click on settings and scroll down to API. Simply click on create new token. Then click on continue. This will automatically download a Kaggle API, as in a JSON file in which your API and your password will be inside. Here is it. So afterward, the downloaded Kaggle API, you copy it and paste it in your Kaggle directory, in your created Kaggle directory here. This is where we download the dataset, the Kaggle JSON file. We'll simply copy it and paste it in the downloaded directory. Copy, then we paste it here. Right click and paste. Here is it. So let me quickly edit that so that, because I've already downloaded it already, so let me edit it so that it will be in this proper format. All right. After doing that, the next step is for you to search the data. We are using the Olist e-commerce dataset, right? So simply come here. You can search for Olist on Kaggle by simply running this command, Kaggle dataset list s-s, then Olist. It will bring datasets or all datasets related to Olist sales. So simply run this, shift enter. All right, here are the datasets available that has Olist in them. We are using this first two, that is the Brazilian e-commerce and this marketing funnel Olist. After that, we can download the two datasets by using the Kaggle dataset download the market funnel Olist. So let's go ahead with the first one by downloading it. Simply click shift enter. And as you can see, it has been downloaded, market funnel Olist. It's a zip file and it downloads to this parts on our folder on our system. So we can simply check that out where it downloads. So as you can see, new folder, it downloads to new folder, then to all. That's the directory, that is the folder. New folder, that's the name of the folder, new folder. Then we simply check for all in new folder. Click on all. As you can see, we see market funnel Olist. The first data set has been downloaded. So let's move to the second one. Shift enter. And wait for it for a couple of while to download. And now, as you can see, the second data set also has been downloaded. Brazilian e-commerce zip. It also downloads to that same folder, the user desktop new folder all. So let's cross check. Yeah, it's in there already. So we can refresh. As you can see, the Brazilian e-commerce, it's already there. So let's extract those two files. Yeah, we are done with the first one. Let's also extract the second one. Okay. And here is our extracted data sets. The first one, Brazilian e-commerce, and the second one, the marketing funnel Olist. So next, let's move to how to access those downloaded data sets. We want to know those data sets in there. So we run our import OS. Then afterward, we want to check each folder, the type of data set in there. So let us simply click on the Brazilian e-commerce. We'll copy the path and paste it to our OS list directory. We'll paste that. We'll change that slash as in the backward slash to forward slash. Then the name of the data set, which is Brazilian e-commerce. Okay, Brazilian e-commerce. It's incorrect. Let me quickly adjust that. Brazilian e-commerce. Okay, there's an hyphen in between the Brazilian and e-commerce. E-commerce. All right. And here are the data sets in the Brazilian e-commerce folder. As you can see, there are various types of data sets in there. We have the Olist and the likes. So let's also do the same thing for the second one, which is the markets, Olist funnel market, or what's the name? Let's cross check. Marketing funnel Olist, I mean. So let's simply copy it as it is and paste it here. Control V. And let's run that. As you can see, we only have two data sets in the marketing funnel Olist. So for this analysis, we'll be using some certain data set like the orders data set and also the product data set. We'll be using that. And also the two data sets for the marketing funnel Olist. So making the 4 data sets that we'll be using. So let's move ahead to process the data sets. Let's load the necessary libraries. We can simply load them by importing pandas, numpy, and the likes and run it. Shift enter. Then we are loading our data sets using the pandas. As you can see, we are loading the 4 data sets. However, there are 5 in numbers. The first one here is the closed use data set. The second one, which is the marketing qualified. The third one, product name. As you can see, I made mention of 4, but it's 5 actually. We'll be using the product category name translation also. So, which is the 4th one over here. And lastly, the other data sets. So we can simply load this. Shift enter. We can see some, as in let's play with some view of the data, like the CLD data. Let's see the first 5 entry. As you can see, we have the MQI, MQL ID, seller ID, SDR, and the remaining features in the data set. We can also view the product rename ID also, as in the product rename data sets, product rename .add. As you can see, we have the product name category, product category name, and the product category name English. It's simply the table set, as in the data set is simply translating the Portuguese written name to English written name. So next on, we'll move on to the checking missing values in the data sets. To do this, since we have about 4 data sets to check, instead of us checking them one after the other, we can simply just use a function to solve that. Let's declare a function called summarize missing values. Summarize missing values. And in this function, let's pass our data frame in it. A data frame. For this function, what this function basically does is that it will find the missing values in our data sets, also find the missing value percentage, the percentage of each missing features. If you are talking about missing values here, they are our null value, they are empty values. It will find the missing values, the count of those values that are missing. Likewise, the percentage of each features that are missing. So let's declare a variable here called summary variable. and let's give it an empty dictionary like that, because it will be later useful when we want to form our data frame table. So let's say for name and df in our data frame, for this particular data frame, we'll split it in such a way that we'll have name and df. Enter. We need the missing values, and to find missing values, that will be df, which is the data, our data set itself, dot is null. Is null simply find any entry or any row or column of our feature that is empty. Then it should count, it should sum up the numbers of those missing values in it by using the dot sum. Then, since we said we are finding the percentage also, we need the total entries, that is the total row in each and every data set we have, so that we can divide that with the missing value. So that will be total values. We can simply declare this by saying df.shape, then the first entry, which is row. This simply take the total number of the rows in each data set. Take for instance like this, our product rename data set. If we say product rename.shape, it will simply bring the rows and column. This product rename data set consists of about 71 rows, that is 71 entries, and the columns there are 2, as we can see, the product category name and product category name in English. So this index is 0, the row index is 0, while the column index is 1. So we are simply picking out the rows index here. That's the meaning of this 0 over here. So then for us to find the missing percentage, we divide the missing values with the total values. So we are dividing the missing values divided by the total values. Then we multiply that by 100. We multiply that by 100 to get our percentage. Then afterward, we'll declare our data frame, the data frame we are using. Just like a data frame is just like a table that has rows and column. So to do that, we can simply say the missing df, that is the missing value table itself, missing df, the data frame. Let's form the data frame by using pd data frame. And what will be inside our data frame? Which, as we said earlier, we need the missing values and the missing percentage for each values. So there we have the missing, let's say the missing count, that is the total numbers of those values being missing in each data set. So in here we'll attribute it as in, this is the key, the value here will be the missing values over here, comma, then the missing percentage also, the missing percentage. Then for this we'll have our missing percentage over here. Then for this, we only need those features of the data sets that are missing. Those ones that doesn't have any null value or any missing value in them, we don't want them. So to differentiate between that, we can simply use query in pandas to differentiate that by simply using query where our missing count, the missing count is greater than 0. We only need those features with missing values only. So greater than 0. All right. Then let us map the missing values and the missing percentage to the name, that is CLD to CLD, MQL to MQL, and the remaining parts also. So whenever we have the missing value counts and the missing percentage, it will be each of them will be classified based on those data sets we have. That is, the missing values and the missing percentage for CLD will be for CLD, and for MQL also be for MQL, for products same thing, and for other also same thing. So that's the main purpose of we declaring name and DF in our for loop over here. DF is the data set, each data set we have in our that we are working with, like the CLD dataset, the MQL, the products, and the other. Why the name is the given name that we want to give our data frame. You know, we have a new table now, and the new table will be showing the missing values and the percentage of each missing value. Summary name. We are saving this also into our missing DF, that is the missing data frame. Then afterward, we'll return summary. Return summary. The second step here is to assign names to the data frame for our summarization. So let's say missing summary equals, let's call our function summarize summary. Summarize means missing values. Then we can simply put this as a list. The first one here, just as a list of tuples by saying the CLD, we are associating this with the data set, which is CLD itself. Then for the next one, which is MQL, we are attributing this to the MQL data set. Then also for the product association this with products. Then finally for order, we are associating this for order also. So let's print that and see what we will have. To print the summary with handling for empty results, we'll say we declare a for loop for that by saying for, or we can simply just do all this in another column so that it will be more neat, so that we'll know that this is our function, right? Let's run the function over here, then declare this here. Let's say for name and DF in missing summary, in mystery summary dot items, this is the name, these are the DFs, CLD, MQL, that is the read data set itself. This is the name we are attributing to them, which is still the same thing as the name of the data sets. So this, let's say print, let's use an F string over here, summary for name, yeah. So let's see what we have here. And we can also take care of any empty, if the data set is empty, we can also take care of that by using the if statement, saying if the data set is empty, it should return, or it should print, let's say no missing value, no missing values. Else, it should print out the data set for us by saying, using another F string over here and the DF here. So let's run this and see what we have. Oops, we are getting an error over here. It says name missing percentage is not defined. What's that? All right, I think we made a mistake here. We have to put equal sign here. Let's run the function again and run our, still encounter another error. Invalid syntax for this missing count greater than 0 here. That's our query. For the COD datasets, these are the missing columns in there, like the business segments, lead type, and the rest. And these are the percentages of each missing feature. So for the MQL, we also have a missing value over there, which is origin feature. And for the products datasets, here are the missing values there and their percentages. As you can see, most of the missing percentages are very low, very less than, as in not up to 5% of data sets. And for the summary for other, we can also find out that the missing values there are relatively low compared to CLD dataset, that is the closed deals dataset. There we have about some of the features like as company, as GTIN, and average stocks, and also declared products category size. The missing values there are about almost 100, as in almost 92% all true. 92% or 93%, 92, and also this also about 92% missing values, which is quite huge. So let us undo the missing values here effectively. For those features that their missing values are less than 5%, we can simply drop them directly. So like, let's take for instance, in the CLD dataset, the business segment is less than 5%, lead type is also less than 5%. Likewise, the business type is less than 5%. We can simply drop those ones that are less than 5%. Let us undo the missing values for the first dataset here, which is the CLD. So, and take note, whenever you are handling missing value in a dataset, try to duplicate the dataset, have another copy of the dataset. In case there might be any issue, you can still revert back to the original dataset. So let's do that. Let's copy those our data sets. Let's have a copy for them. Let's say this is clean equals cld.copy. And let's do this for the remaining data sets also. The MQL. Let's say this is MQL. Likewise, this MQL. Then the third one, product. Then we are also copying this also as product. Then finally the order table, order, and this also order. So henceforth we'll be using CLD clean, MQL clean, product clean, and order clean for any analysis now. So let's simply run this. So for the CLD column, we are dropping those values or those features that their missing values are less than 5%. CD clean, we are dropping all those null value. The subsets, we have the business segment. That's for the first data set. Then for the second data set, you have some missing value here for the origin. So we can simply drop that for the MQL data set. So we can simply say MQL clean dot drop now. Also for the next data set, which is products, all right, here are the features that we are dropping. Starting from the CLD dataset, we are dropping the business segment, lead type, and the remaining. Then finally for the other clean data, we are dropping 2 of them. I intentionally exempt this order delivered customer dates. I did not drop it because it will be very useful for us when we are calculating the delivery distribution. For those null entries in order delivered customer dates, that is, the order delivery customer date basically is feature that tells us whether the product has been delivered to the customer or not. Whenever it's being delivered to the customer, it will be as in the dates and time will be registered in the database. However, if not, it will be null. That shows that a null value there means the product is yet to reach the customer due to any factor. So I intentionally leave that because it will be useful for us when we are calculating the delivery distribution factor. So let's simply run this and see what we have. We can simply rerun our function to see if these have been effected. So let's simply recall our function back, the missing summarizing function. We'll paste it here, but this time around we are using the clean function, clean data sets for them. And finally this. So we can simply run this and see what we have. Alright, as you can see now, for the summary, for the CLD, the closed deal data sets, it only shows the remaining unclean data, as in the missing values, while for the MQL, no any missing value there. Then for the summary product table, no any missing value there. Then for the delivered customer dates, which we intentionally leave out, so it's also there. We are leaving that actually. So let's move ahead to clean the lead behavior profile. As you can see, this is greater than 5%, but not as much as the remaining features over here. Let's find a means of inputting for the lead behavior profile feature. So to do that, let's firstly see the distribution, how it looks like. The distribution of each of these missing values. That will guide us on what to input for them, whether we are inputting the mean or the median or the mode and the likes. So to do this, let's say columns, the columns to plot equals, we are plotting the lead behavior. Here are the columns. So let's have a figure here by using the matplotlib figure. Let the fixed size here be 12 by 8 I think 12 by 8 is good to go. 12 by 8. Then let's look through the columns and plot their histogram. So let's say for I and column, in each columns, let's have a subplot, let's say 2 by 3, that is 2 rows and 3 columns. Since we are dealing with about 5 columns over there, so we can simply use 2 by 3 subplots. Subplot should be 2 rows by 3 columns, then I for each column. Then let's use the Seaborn histogram east for the CLD clean. Then column, it should iterate on each feature in the column. Then our bin, we can simply put the bins to, let's say 20, and let's add the title. The title can be each title column. Then afterward, we can plot title layout, and let's go to off, shift enter. Columns is not divine. All right, seems like there is an error here, a name error, columns here. All right, here is the display of the columns that will have the distribution of each missing values feature. As you can see here, for the lead behavior profile, we have, it is being right skewed. We have more entries of cats compared to the remaining parts like eagle, wolves, and some of the features here as in somehow mixed together. We have wolf here. We also have another wolf over here. That means there's something wrong in there. We are coming back to that. Then as company, also we only have 0 and 1. 0 and 1, that is a boolean, as in a boolean value, which might be yes or no, true or false. We also, as in, we'll take a look at the unique values in each of these columns. Then coming down to the average stock is also being grouped in ranges like 20 to 50, 1 to 5, 5 to 20, 20 plus, 200 plus, and the likes. We also have some unknown values there. Then finally, the declare products catalog. It's also as in right skewed. Majority of the value lies between 0 and 500, while few of them lies between 1000 and 2000. So starting with the first column over here, which is the lead behavior profile. So let's see the unique values in there. Let me simply copy it from here. We have the CLD clean, the unique values here, the unique value. Let's see. Oops. As we can see, there are some values that are repeating, like cats, wolf, just due to some inconsistencies in the arrangement. Some have some trailing spaces and the likes. So we need to adjust this. We can simply use the lambda function to adjust this by simply saying CLD clean behavior profile over here. Let's declare a lambda function for that. Let's apply it here. We're applying a lambda function. Let's say x lambda, such that if x in, let's have a dictionary of the correct names. The unique value here are only 4 in numbers: the cat, the eagle, the wolf, and shark. But the remaining parts, as in the remaining writings, are just as in some mistakes in the due to the data entries and the likes. So we'll simply write those unique value like cat, and finally shark. Also, there are some missing values also that are in the data set, like this NaN, that is not a number. So we use the numpy function for that, NaN in numpy. So if this exists, it should return X. Whereas if not, our else statement should return an empty value. So we'll run this on our lead behavior profile and see what we'll have. We can simply run this on it so that it will replace any values that are there before. So shift enter, then let's recheck the unique values there again and see what we'll have. All right, as you can see now, the function has already been applied on that. So all these inconsistencies in the entries has been arranged. So the unique value in the lead behavior profile now is the cat, eagle, wolf, and shark, and some non-values over there. All right, so let's undo the missing value for the lead behavior profile, because it only has about 21%. So, and as we can visualize, or we can revisualize the lead behavior profile here. So we can just say sns.eastplot. We are plotting this, and let's see what we have. What's that? East plot. All right, as you can see, the cat has the highest entry in here. So simply, since our data here is categorical data, we can simply input the mode for the missing values for the lead behavior profile. So let's simply do that by inserting the mode for that. So let's have the data set back here. Dots. We are filling any empty value here. So we are filling it with the mode. So I'll replace that, paste that there, then mode. Then the first value of the mode, if it has many modes, but we are taking the first here. So we'll close that and also replace this here too. So we run this cell to check. Now this cell, what this cell here over here is doing is simply replacing those missing values in the lead behavior profile with the mode, and the mode here is the cards category. So let's simply recheck if there's any null value for the lead behavior profile here. So let's check. Is null dot the sum of the null values here, as you can see here, now is 0, meaning that for the lead behavior profile now we are done with that. Then next to the as company and as GTIN, let's check the unique value in them. The as GTIN or as company first. As company, the unique values there. Right, the unique values there are true and false, as you can see. That's the reason why the display is bringing 0 and 1. Same thing also applicable to as GTIN. In this situation in which we have the true and false, whereby we have about 92% to 93% missing values in them, it will be more realistic for us not to use any statistical imputation like the mean, the median, and the mode like that. It will be statistically reliable because it will distort the pattern. Just imagine we have only few true entries here. Then we fill in with the mode, as we inputted the mode for this, meaning that almost 92% of our data sets will be shifted towards the modal value, which is true. So it will be statistically unreliable. So for that, we'll find another means of handling the missing value here. Another way we can look into this is to know if these features in our data sets, if they have any impact in our analysis. If not, we can simply drop the columns. And for the as company and as GTIN, the column simply means as company, that is the lead generated comes from a company. And likewise, the as GTIN, does the lead generated as the GTIN. GTIN is just a number, meaning global trade item number. Those are the specific number or the unique identity for any product. Any product. It's an internationally recognized system for identifying any product. Does this particular feature, do we need it? Do we really need it in analyzing our sales funnel? If not, we can simply drop it. So for that, we'll be dropping the as company and as GTIN, as we are not needing it for our sales funnel analysis here. So let's simply drop those two columns. To do that, we can simply use the drop function. So we are dropping the as company and as GTIN. So that will be drop the column we are dropping, the columns we are dropping, that will be the as company and as GTIN. So we are dropping these two. So let's simply insert it here. so that we'll have bits. So we are using this. So simply click Shift Enter, and that is done. So we can simply check the unique columns in our CLD clean dataset now and check the columns here. As you can see, now we don't have the as company and as GTIN again. Well, for the remaining two parts, that is the average stock and the declared products, declared products category, the average stock and the declared products category size, we can also undo the missing value by simply dropping those two columns. So let me simply copy this, clean as in, okay, where is it? Yeah, let me simply copy this and paste it here, Control V. So we'll simply edit that to average stock, average stock, and the second one also to the declared products catalog size. Then let's simply run that. Declare product catalog size. So let's simply run that. So let's check if those two columns has been dropped. So let's check cld.clean.columns and let's run that. As we can see now, those two columns have been dropped. We can't find the average stock and the declared product catalog size again in there if you compare the two columns here. So afterward, let's check for some duplicate values in our data sets. As we know that duplicate values are very essential in checking. So to check this, we define a function for that by using the def summarize duplicates. Let's call the function summarize duplicates, and it is taking some parameters like data sets. We put asterisk in there just to demonstrate as many as possible data sets can enter that, and names, that is the names of the data sets that will appear as the data frame name. So we set that to none. Then this function will return a pandas data frame. So we'll pass in some list comprehension in it. Some list comprehension in there, like we need the data set, that is the data set name, like the data set name. Also, we also need the total rows in the data sets, total rows, and to do that is simply the length of the data set, df. Then finally the duplicated value, that is the duplicate rows. Also need that duplicate rows, that will be df dot duplicated. Then we'll sum it up dot sum. Then finally we'll merge the two sets together by using a for loop. We are zipping the data sets and names column together. We are zipping the data sets and the names column together. So for df name in zip of the data set and names. So this two is simply merging the data sets, is mapping it to their name. If you have the names like the CLD, just like we did for the other time, CLD, MQL, products, and other, it will simply map them to their respective, and let's call the function on our data sets summarize duplicates. Then we call those data sets in there. We start from the CLD clean, then the MQL clean, then finally the names. So the names here that we are mapping to will be CLD, comma, MQL, in quotes, MQL, then comma, product, and finally the order. So we run that. As you can see here, we found out that our data set doesn't contain any duplicated rows. The duplicated rows all through are zeros. So afterward, in here we'll also discuss some of the metrics that we'll be calculating for. These metrics will serve as our major focus that will display on our dashboard. Some of these metrics include the funnel conversion rates, the time-based metrics, we have the product analysis, we have the sales team performance, we have the landing page optimization, behavioral insights, other metrics, customer retention. We also have the full funnel analysis, and finally the bottleneck identifications. This is where we'll stop for this lecture. In the next lesson, we are going to be analyzing these metrics listed below. Thank you for listening. See you in the next video.